the slide that talks about basic property of common logarithms. What a common logarithm is that the base is 10. So in all these situations, you have log with a base of 10. If you have log base of 10 of any number, what they'll usually write that is just log without writing the base to the number of x. This is the same thing as, when we talk about a square root versus like a cube root. If we were going to write a cube root, you would put a 3 there. But if you had a 2 there, it would be the square root. Now, if I had it like this, you'd say that doesn't look normal. Normally, we just write it as square root of x. It's the same concept, where when you see a square root without that number 2, you just assume it to be a 2. It's the same thing with a logarithm. If you don't see a base, the base is 10. So that's just common logarithms there. So here, it says evaluate this. Not only do we set it equal to x, I'm going to put it in right here that the base is 10. So I have 10 to the power of x equals 10,000. And so to solve this, it should be easy. There's 4 zeros, so this should go in 4 times. Let's check it. 10 goes into there 100 times. No, 1,000 times, I'm sorry. You just take off a 0 every time. So I divide it again by 10. And this time when I divide, I would be left with 100. I would do it again, and I would divide by 10. And this time I'm left with 10. So that's 10 to the 4th equals 10,000. And so x here equals 4. All right, that 4 didn't hardly show up all the way there. Let me straighten out so you can see it just a little bit better. There we go. All right, let's try this one. This is an exponential form. So this is my base. This is my power. It's got to be equal to some number x. So if I converted it, I'm in exponential, I need to change it to a logarithm. I would say log, my base is 10, to the number, which is x, will equal the power, which is log of 12. Notice how the bases here technically are the same, so my x would simply be 12. So you'll start to figure out with logarithms and exponentials, a lot of times it's just converting back and forth and they become really easy to solve. Let's try this one. Now we have something a little bit more difficult, I'm sorry. So we would say 10 to the power of x equals 14. And notice we can't solve this, so we're going to end up doing a different property later on. But for the most part, what you would do is you could type that into the calculator and find out an answer. But here, we wouldn't be able to simplify by hand and do this one. So I would leave it like that, or I would go over the calculator and just type in what we had originally, which was log, log, you put the 10 there, except my calculator's not cooperating, 10 there, a 14, and you'd press enter, and that there would be our answer. I'm going to delete this so it doesn't get in our way here. And now this would be our answer to this. Okay, and now this one here, you're going to say base 10, power of x. 10 to what power equals a negative 11? The answer is no solution. What you cannot do is take a logarithm of a negative. That's like the number here. You can't have a negative number. It's not in the domain. I haven't shown you a graph. I'll show you one real quick. If I went over here, added a graph, and we did logarithm, and I'm going to do 10, and it doesn't matter what the number is, you'll see that the graph just doesn't exist on the left side, so you can't have a negative x value. It's just impossible to do. So here, its domain does not exist. When x is less than or equal to 0. Just doesn't exist at all. So here's one for you to try.